So with this one problem, it begins with Riemann sums, which we did at the beginning, and then integration, which we did at the end of the chapter. So divide the interval from 0 to 4 into 50 pieces. So you'd have the size of each one, delta x, is going to be 4 minus 0 over 50. So 4 50ths, or 2 25ths. And then for Riemann sums, I take the interval, sort of exaggerate a little bit, and say the first one has to go from 0 to 2 25ths. And then this would have to be, let's see, this last one, I have to go from 4 backwards by 2 25ths. So it's going to be 4 minus 2 25ths. So let's see, that would be 100 minus 2 is 98 25ths. And this equals 100 25ths. Okay, so then I'm going to use the midpoints. So the midpoint here would be half of that, so it'd only be 1 25th. And I'm going to use the midpoint of this interval, and if that's 98 and that's 100, this must be 99. And then sum the sequence. So the height of each rectangle is going to be given by the function x over 1 plus x squared. Then that needs to be multiplied by the width, which is 2 25ths. So times 2 25ths. And then have it x go from the beginning 1 25th to this one, 99 25ths. And the size of each increment is going to be the delta x. So to list, math, sum, list, operations, sequence, and then let's see, I got to be a little bit careful. X divided by parentheses 1 plus x squared gets multiplied with 2 divided by 25, with x going from 1 25th to 99 25ths in increments of 2 25ths. Okay, and then use actual integration to find the exact answer. So integrate x over 1 plus x squared with respect to x going from 0 to 4. So this looks like a good candidate for u substitution. Let u equal the denominator, because I see that if I take the derivative of that x dx is sitting on top, and I get x dx right there. I just need to multiply both sides by 1/2 so that it's set up perfectly for the u substitution. So we get that this is going to become integrate. The numerator becomes a 1/2 du, and I let the whole bottom part equal u, so it's du over u. Notice I did not put the 0 and the 4 because the 0 and the 4 are for x. So what I'm going to do is just leave the numbers off until the end. When I change it back into x, then I'll put the 0 and the 4 back. The next thing to do is recognize this comes from the natural log function. So the antiderivative would be the natural log of u. And we don't need to put plus a constant because we're going to be substituting these numbers in. But I should change it back to the x's, so replace u with 1 plus x squared. So it's natural log 1 plus x squared. And now put the 0 and the 4 back. So we've got 1/2. If I put a 4, that's going to be 16 plus 1 is 17. Minus, let's see, if when I substitute a 0, it's going to be 1/2 natural log, and then that's going to be 0 squared, so it's going to be natural log of 1, which equals 0. So we've got our estimate of 1.417, and then our actual answer is 1/2 the natural log of 17. Hey, that was a pretty good estimate.